our last video, we identified a multiplicative pattern where you multiply a number by x to find y. In this video, we're going to introduce a different type of relationship. As you can see on my scenario on this screen, I share a birthday with my brother. We have the same birthday. When I was 8, he was 3. When I was 12, he was 7, and so on. The first thing I'm going to want to do is be able to identify the rate of change by calculating delta y over delta x, just like we did before. Now, looking at my age from 8 to 12, that indicates that that is a change in 4. That means that 4 years have passed for me between my years of 8 and 12. Guess what? That is true for my brother as well. That when 4 years passes for me, 4 years passes for him. Looking at 12 to 15, the change for x for this is 3. The change in y, when 3 years passes for me, 3 years passes for my brother. The change from 15 years to 19 years, so the change in my x values is 4. And the same is true for my y values from 10 to 14. From 19 to 22, that is a change in 3. And 14 to 17 is also a change in 3. When I identify my delta y over my delta x, which is my rate of change, if I look at my first set of values right here, I will have plus 4 and plus 4. I don't really need to write the pluses in each one of these cases, so I'm just going to write it as 4 over 4. When I simplify, that equals 1. If I do the same thing for these set of values right here, the change of y over the change of x is 3 over 3, and when I simplify, that equals 1. In the last video, we took our rate of change and we multiplied it by our x value. So let's try that here. I enter my 1. I bring over my 8 from my x. Now I'm hoping that if I multiply 1 times 8, I will get my y value. That is not the case because 1 times 8 is not 3. And honestly, it makes sense when you think about it because I don't double or triple my age as I get older compared to my brother. Notice that we change the same amount by years each time. So multiplying isn't going to give me what I'm looking for, but there's another operation that might. How do I get from 8 to 3? Well, if we think of something other than multiply and divide, we might come up with add or subtract. That means if I take 8 and I subtract 5, do I get 3? Yes, I do. Let's check that with the next row. I'm going to add my rate of change again, which is 1, entering in my x value so I can multiply it, and then I'm going to bring in the minus 5, because that is the pattern I'm hoping to see. So when I multiply 1 times 12, that equals 12, minus 5, it equals 7. As it happens, this 1 value right here doesn't actually change the 12 value. So really, we don't need it in there, so I'm going to drop it. Let's continue. I'm going to bring over my 15 from my x value, and I'm going to subtract my 5, and I get 10. My 19 I'm bringing over from my x value, subtract my 5, 19 minus 5 is 14. 22 minus 5 is 17. So my pattern holds through the entire table so far. If I were to replace these values that we have in the x column and replace it with just an x, I would rewrite that as x minus 5, and that does equal my y value. So as an equation, it would simply be x minus 5 equals y. As it happens, I could have changed this from 22 minus 5, and instead I could have had it as 22 plus negative 5. Guess what that equals? 22 plus negative 5 is 17. So another way of writing this equation could have been x plus negative 5 because it results in the same answer. Minus 5 is equivalent to saying plus negative 5. That means that the relationship that we have identified here is not a multiplication relationship or multiplicative. It is in fact an additive relationship where we have added or subtracted something.